Hello. Today we will going to discuss about container orchestration. So why we need orchestration, what benefits we can get from orchestration, we will discuss this in today's video. Let's start with a simple use case. And a simple use case can be that we have an application which is containerized application. Containerized application means we already using some container. Right now, the popular container technology is the Docker, but there are other players as well. So I have a front end application and it's a Dockerized application. I have a backend application, and this is also a Dockerized application. I have deployed these two containers somewhere. So let's say I've deployed it on a server, and I have a database. So I have two options. Either I can create a database, a containerized database, or I can have a database outside, let's say maybe a cloud service. I'm using some cloud database. So let's keep it simple and outside. So it's some cloud database I am using here. And I have some users who will gonna use my application. So they use my application, and then front end actually calls the backend, and the backend calls the database. So it's a very simple application deployed on one server. Now, the limitations that I have is if I have a limited number of users, then it's okay to use. I don't have much load, or I have a predefined number of users. For example, if I have, let's say, 1,000+ users, and it's some regional application, it's only specific for some community or some group of people, then it's all fine. But what if I want to scale and I have large number of users, then what I can do? So what I can do is I can do the horizontal scaling. Now in horizontal scaling, we add up more servers. So let's add some more servers. Now I have added one more server in my for my application. So now the main problem is, if I have a user, so where my user going to, which server is going to hit? Will it hit server 1, or let's say this is server 1 and this is server 2? So which server my user going to hit? So in that case, this is obvious that I need a load balancer, right? So the load balancer will forward my request to the appropriate server. So let's say I have a load balancer here, and the user gonna hit my load balancer, and then the load balancer will distribute the load. So now I will have to manage the load balancer, and I will have to manage the application. So I have to deploy this front end and this back end application manually on this new server, and then I have to manage them as well. So let's see what we have to do now. We have to deploy the application manually. We have to deploy the Docker instances. So what are the steps? What I have to do? I have to set up a machine. I have to deploy the Docker, the application, the Docker instances. So I have to deploy the Docker instances. So I will say Docker containers, right? And I have to manage the load balancer also. So I have to deploy the load balancer and have to manage the load balancer as well. Now, for example, I have a new service which I want to connect. I am using some services. Let's say I am using some third-party payment services. So this is a third-party payment service, and I want to change my backend so I could connect to my third-party payment service. So in that case, I will have to deploy a new instance. I will have to deploy a new instance manually on my server 1. So I have to deploy a new instance. Let's say, so this is a new backend instance I have to deploy manually here, and also I have to deploy on the server 2. So I have to deploy the backend instance here as well. So again, I have a manual deployment um, of instances. So we have to do the manual deployment. So these are the issues you can, as you can see. And now if I want to scale, I want to scale one more instance, right? So I want to add up one more instance, since, for example, if my application is getting more traffic, it's getting more attention. So in that case, again, as you can see that if I use another instance, then it will be a manual deployment for the front end and the back end. And also, if I change something later, if I change my backend code or if I change my front end code, then I have to manually deploy on server 1, on server 2, and on the server 3. So the orchestration platform actually manages all these things for you and make your life very easy. Let me show you how orchestration platform can handle all these things for you. There are two popular platforms for orchestration. One is Docker Swarm, and the second one, which is the most popular, that is Kubernetes. The Kubernetes is the most popular one, and it's widely used and accepted. And Docker Swarm is on a small scale to medium scale applications, and for large scale applications, Kubernetes is most recommended. So how this platform works actually? So we are trying to understand the general working of these platforms. So in an orchestration platform, we have a cluster in which we have a master node. So for example, this is a master node, and then we have worker nodes. We can have multiple worker nodes. Let's say right now I am taking 2 worker nodes, and the master nodes actually handles and manages all the worker nodes, their health, their instances. The master nodes actually handles everything. Let's say we have the same application and we want to deploy the same application. So what we can do is we will deploy the same application using a YAML file. So we can write a YAML file, right? We can write a YAML file, and then we will deploy this YAML file. We will deploy the YAML file. So when we deploy this YAML file, we write all the configurations in this YAML file, and that is then the orchestration framework takes care of it. So let's try to understand a bit deeper. So we have a backend application here. We have a front-end application here, right? And if we use the replication part, so we say that these instances should be replicated. So we can have a one instance of backend, front-end, and the one instance of backend, one instance of front-end, and one instance of backend. Now the master node is going to handle the load balancing of the traffic. So the user going to hit the master node, and the master node then takes care of the traffic, and it also takes care of the deployment. For example, if I want to change something in the backend, for example, if I want to change my backend, right, then I will just simply redeploy this YAML file. I will just simply redeploy this YAML file. For example, I have a new version. I will redeploy my backend, and the master node will also update the instances to its worker nodes. So I don't have to do it manually. Instead, it will be managed very perfectly and very easily by the master node. And with that, we also have a very good feature of networking. The orchestration platform creates a network of different instances. So these all are part of a network. And since they are part of a network, they can access different instances. So for example, this front end, if this front end wants to call this backend, this is also possible. For example, for some reason, one of our instances goes down. Let's say, for example, if this backend instance goes down, then it's very easy that since they are in the same network, all instances are in the same network, they can communicate with each other using their names and using their IPs. So this all is handled by the orchestration framework as well. Again, when we want to scale, let's suppose if I want to add one more instance here, so I just have to use, or I just have to add a worker node. Now this will become a worker node, and as it will become a worker node, the master node will create the front end and the back end instance in this new worker node. So scalability is also handled by the orchestration platform. Now we have an interesting point here. What happens if the master goes down? Now if the master node goes down, then who will take charge? Now we have, so that's called an election process. So that's called an election. So in the election process, if the master node goes down, then one of the worker nodes will take charge and will become master. So in that case, we can say, for example, if the master node has gone down, so this one has become master, and now it will be now this master will handle the everything, which is the load balancing and health of containers. In this way, we have the high availability feature, so that our system keeps on working and it's highly available. So in a summary, what we discussed today is the orchestration platform and the responsibilities of orchestration platform. The major responsibility of orchestration is to manage the cluster, to manage the container instances, to handle the load and to distribute the load between worker nodes, to check the health of different instances, and to keep the minimum required instances which is defined in the YAML file. And also it handles the network and scalability and the election process. If master is down, then one of the worker nodes becomes the master and handles the traffic. So I hope this will be helpful for you, and I'll see you next time. Thank you.